Hello student, welcome back to the channel Positron. This is a uh, this is a first chapter of 12th. You can say that electric field and electric intensity. In my first video, I have discussed about charge and its properties. In second videos, it was the Coulomb's law and vector form of Coulomb's law. And today's topic is electric field and electric field intensity. Dear students, electric field actually is a literary word. Field means impact. Impact around a charge. The volume around a charge in which any other charge is either attracted or repelled by particular charge is called to be the field of that charge. Field means impact, effect. For example, might be your dad would be very famous. He has the impact around the city. I mean that if just you take the name of your dad and everybody knows that that person lives there. If you talk about the chief minister of your state from where you are watching my videos, undoubtedly every person in the state will know him, that he lives in the capital at a particular place. It means throughout the state he has the impact. But if you ask about the Modi ji, that across the globe people know him, right? So he has the impact across the globe. So electric field is actually the effect of a charge around the volume in which any other charge experiences attractive or repulsive force. Now, dear students, the mathematical significance of electric field is electric field intensity. Now, electric field intensity is defined as vector E is equal to limit Q naught tends to 0 F upon Q naught. Now, dear students, what it is? Actually, the electric field intensity at a point due to a charge is the force experienced by positive test charge at that point. Electric field intensity is defined as the force experienced by unit positive test charge at that point. This means nature of electric field intensity is the force. It is actually the force experienced by unit positive test charge. Just later on, few days after, in my next video, I'm sure you will study about the electric potential, which is defined as a work done in bringing unit positive test charge from infinity to a point. So the nature of electric potential is a work done, whereas nature of electric force is a electric field intensity is what? That is a force. The electric field intensity at a point is the force experienced by unit positive test charge at that point. Now, dear students, E is actually F upon Q naught. If you want to find out the dimension of a unit of E in MKS, you can write this is Newton per Coulomb. Newton per Coulomb. You can find the dimension of electric field. When I was making my videos on the that is first chapter, dimensional analysis, then I have said just only 2, 3, 4 dimensions I have discussed with you all, and I have told you all that as soon as time will come, you will be familiar with the new physical quantities, and at that very moment we should discuss the dimension. And the dimension of electric field, F is a force, MLT minus 2, and Q is not a fundamental quantity. You know, charge is not a fundamental quantity, but current is a fundamental quantity. I is equal to Q upon T, so Q is equal to IT. So charge, that is Coulomb, is ampere into time, so it is A into T, and if you will bring this to the numerator, then it becomes MLT minus T. This is T minus 1 minus 2 T minus 3 and A minus 1. This is the dimension of electric field intensity. Again, I am repeating my words. Dear students, how will you define the electric field intensity? It is the force experienced by unit positive test charge kept at a point. Now, what I have said, that the nature of electric field intensity is the force actually. It is a force, right? If, dear students, it's a very important in physics that you should know the nature of a particular physical quantity, then it will make the things very easy and concept very clear. Now, dear student, simply it is a force experienced by unit positive test charge, that is said to be the electric field intensity, and unit of electric field intensity is a Newton per Coulomb in amperes. Now, very interesting, why it is written that limit Q naught tends to 0. Q naught is a positive test charge. Why do we consider positive test charge? Dear students, it has been internationally recognized. There's I don't think there's any explanation behind it. Like your name, your dad, your parents has said you Ranjan. My parents said me Ranjan, so I'm Ranjan today. If my parents would have said me Bablu, then today I would have been Bablu. Similarly, the internationally it has been recognized that everyone, in order to get the same direction throughout the globe of electric field intensity, that is why there should be no confusion in regard of the direction of electric field intensity. That's why we suppose that positive test charge. Now, dear student, why do we keep Q naught tends to 0? Look here. Let here is a charge Q, and at a small r distance apart, we are considering a point P where we have to find out the electric field intensity. Here is a charge Q, a small r distance apart, a point is P where we have to find out the electric field intensity. Now, dear students, in order to very first, every field, whether it is an electric field, gravitational field or magnetic field, is a vector quantity. Every field is a vector quantity, so it has the direction. Now, the direction of electric field intensity at point P will be what? In order to know that direction, we are keeping a positive test charge here. Either you keep or not, just keep imagining in your mind. Now, this very charge will repel to this charge along the line joining the two charges, right? This very charge will repel the charge along the line joining the two charges, and that's why the direction of electric field at point P is this is a vector E. Now, the force, now look here, dear students, we consider in the definition of electric field intensity, we say that the force experienced by unit positive test charge. This charge, the positive test charge, should be very little, but it should not be 0. Limit Q naught tends to 0. It means Q naught is the positive test charge is a very little, but not 0 at all. Why do we consider very little? Because you are just trying to find out the electric field at point P. Electric field is a vector quantity. If the charge Q naught, the test charge which give you, that is why you are using the Q naught, just to get the direction of electric field at point P. We are using the Q naught positive test charge just to get the direction of electric field at point P. Now, if this charge will be bigger, then it has its own electric field. And in that condition, you have to consider the net electric field. But right now, we have to find out the electric field due to Q. If it will be bigger, it has own electric field, then in that condition, the net electric field will be the vector sum of two electric field. But our objective is, our motive is to just find out the electric field at point P due to this very charge. That is why the positive test charge should be very little, and limit Q naught tends to 0 means the charge assumed positive test charge is just a very little, but not 0 at all. Now, dear student, how you can find out the direction of electric field? Now look here, the force acting between the two charges, F is equal to Q 1 upon 4 pi epsilon naught Q naught upon R square, right? Now, divide by Q naught both the side. This becomes 1 upon 4 pi epsilon naught Q upon R square. Now, dear student, F upon Q naught, that is the electric field E, is equal to 1 upon 4 pi epsilon naught Q upon R square. Means just by using the Coulomb's Coulomb's law, we have find out the field at point P due to charge Q, which is smaller distance apart. Now, dear students, this is electric field is a vector quantity, so you have to write this in a vector term like this. Now, vector E is equal to, this is the magnitude I am writing same, 1 upon 4 pi epsilon naught Q upon R square. And now, for the direction, what I am doing, I am writing the unit vector R cap. R cap, it is representing, it is a unit vector, means which has the magnitude 1 and it represent only the direction. So, you also can write R cap is equal to, unit vector is a vector divided by its magnitude. So, vector E is equal to 1 upon 4 pi epsilon naught. This is epsilon naught Q upon R square, vector R upon R. So, I am writing here please, E is equal to 1 upon 4 pi epsilon naught Q upon R cube, R square into R cube and vector R. This is the value of electric field at a point P which is smaller distance apart from charge Q. I don't think there is need to much discuss about this. Next chapter, next topic. Let's move further. Dear student, next topic is electric field lines. Dear students, we have to discuss electric field lines and its properties. We have to discuss electric field lines and its properties. What are the electric field lines and its properties? Consider first an isolated positive charge plus Q. We have considered a isolated positive charge plus Q. Now, if you want to find out the direction of the field here due to this plus Q, just put here the positive test charge, and this positive test charge will be repelled along the line joining this. If you want to find the electric field due to this plus Q here, you have to put here the positive test charge, and that positive test charge will be just in this way. It will be repelled in this way. And this is the field line due to positive test charge, due to positive charge. Let's consider here a negative charge. You have to find out the electric field lines. Now, dear students, put here positive. Wherever you want to find out the field due to either positive or negative charge, just keep a positive test charge at that point. If you want to find out the field here, put here the positive test charge, and that test charge will be attracted in this way. So, the positive test charge will be attracted in this way. So, you can say the direction of field line due to negative charge, this is. This is a figure 1 and this is the figure 2. Now, dear students, very interesting. This is a positive charge. We have to find out the direction of field due to this positive direction or the field, and we have to derive the field lines due to this positive charge. In order to derive the field line anywhere around this, I have put just positive test charge. You know, this positive test charge will be repelled along the straight line, and that is why if it is an isolated charge, the field lines will be along the straight line and moving away from the charge. So the field line due to an isolated positive test charge will be just, it will begin from the positive charge and will just move away from the charge. And if it is an isolated negative charge, then how will you find out the field line? Just put the field line anywhere around it, and that positive test charge will be attracted towards the negative charge. So the field line, it will be attracted straight, in a straight manner. That is why the field line will be straight lines and just ending at the charge. Now dear student, how will you define the field line? Field lines are those smooth or straight line, smooth curve in the case when there are the two charges. If there is an isolated charge, then it is a straight line. So field lines are those smooth curve or straight lines on which a positive test charge used to travel freely. The field lines are what? Field lines are those smooth curve or straight line on which positive test charge used to travel. Just I have said that field lines are what? If you want, this is a positive test charge. If you want to find out the field line due to this positive test charge, keep positive test charge around it at any place. That positive test charge will be repelled along the straight line. That is why field lines due to positive test charge will begin from the due to positive charge will begin from the positive charge and move away in the straight manner along the straight line, right? Due to negative charge, how will you find out? Keep here a positive test charge. That test charge will be attracted along the straight line. So due to negative charge, field lines will come from the infinity and will end at the charge, right? These field lines are coming from the infinity and end at the negative charge. Dear students, how can you define field line? Field lines are those smooth or straight line when there is isolated charge, either positive or negative. Field lines are those smooth curve or straight line on which positive test charge used to travel. A smooth curve, when you will get the smooth curve, when there is a combination of either two positive charges or two negative charges. Either two positive charges or two negative charges are kept, or the pair of positive and negative charges kept. In that conditions, always you have to remember that if there is a positive charge, the field line begin from the positive charge and move towards the infinite, and in the case of negative charge, the field line should end at the negative charge. In the case of positive charge, field line will begin from the positive charge. In case of negative charge, field lines will end at the negative charge. Now, for example, if you consider this is straight line is true, field line will be straight in the condition when there is isolated charge. But when you will get the smooth curve, if there is a pair of charges. Now look here. Dear students, here it is a positive charge, that is a negative charge. Now you know in case of positive charge, field line begin from the positive charge. In case of negative charge, field line end at the negative charge. Now the field line will be like this. Yeah, this will be like this. Now dear student, from positive charge field line begins and end at the negative charge. So here these field lines are coming to the negative charge, and here just beginning going out from the positive charge. This is due to positive and negative charge. If a pair positive and negative charge is kept, then field line will be in this way. Now dear student, you can say that why it is curved. If there would have been a single isolated positive or negative charge, then the field line would have been the straight line. But in the case of if you are considering the pair of positive, negative, or positive, positive, or negative, negative, in all that cases, you will get the smooth curve. Why it is so? Dear student, let at this point, these are the field lines, right? If you want to find out the direction, field lines are what? Field lines are those smooth, in case of pair of charges, how will you define? The field lines are those smooth curve on which a positive test charge used to travel. Now, dear student, at this point, now find out the field due to this and field due to this, right? The field due to this will be along the line joining these two, because if you want to find out the field at any point, the first basic concept is just keep their positive test charge. If you imagine a positive test charge here, this positive test charge will be repelled by this along the line joining them, and this positive test charge will be attracted by this negative charge along the line joining two. And now at this very point, the direction of one field due to plus charge is this and due to negative charge is this. Now you have to consider the vector sum of two fields. So at these points, you are considering the vector sum of the field, and that is why it is informal. When you consider a pair of charges, either two positive charges or two negative charges, or one positive and one negative, in that condition, you find you get the resultant electric field, right? And that is why the field lines are straight. Field lines are smooth curve. Why the field lines are smooth curve in case of pair of charges? Because at every point you are considering the net electric field or the vector sum of two electric field due to positive and negative charges. Now, dear students, in case of, if you consider the two positive charges, one is this and the is this. Now, the field line will begin this and it will move like this, right? And it is a positive charge. So, the field line will move away from this positive charge, right? And again, from here also, in the same pattern it will follow. This move away from the charge, field lines move away from the charge, will not be straight line, will be smooth curve, because they are the pair of charges, right? At every point you have to consider the net electric field. That is, a net electric field is the vector sum of two fields. Now these two charges repel. That is why these field lines will repel to each other, right? They are the same charges. In the similar way, if you consider the two negative charges, then the field line will be repelled, will not meet to each other in the same pattern here, but the difference will be here field line will end at the negative charge, right? In this case, field lines were beginning from positive charge. In the case of negative charge, field line will end at the negative charge in this way, right? Dear students, this is the concept of field line. Now, let's move further. Dear students, properties of field lines. We are going to discuss properties of field lines. Let two charges are, one is a positive and the is a negative. Field line will move in this way. Just few field lines are making, just to let you understand, right? From positive charge will begin and end at the negative charge, right? Yeah, in this way. Now we have to discuss the properties of field line. Dear students, what are the properties of field line? First, you know the field lines are what? Field lines are those smooth curve on which a positive test charge used to travel. Field lines are those smooth curve on which a positive test charge used to travel. Now, dear students, the properties of field line. First, at any point, if you draw the tangent in the direction of field line, here it is the direction of field line this. At this point tangent will be this, at this point tangent will be this, at this point tangent will be this, at this point tangent will be this. If at any point tangent is drawn in the direction of the field line, that represent the direction of electric field at that point. It means the tangent drawn at any point of the field line represent the direction of electric field at that point. The very first property is the tangent drawn at a point on the field line, the tangent drawn at a point on the field line represent the direction of electric field at that point. The second property is what? That was the first property. Second property is what? If number of field line per unit area represent the strength of the electric field, the intensity of the electric field, how strong is the electric field, close to the charges, you will see, it will appear and it's true that the field lines are very close, and if you move, for example, if you consider a positive test charge, isolated positive test charge, field lines will be like this, right? So, yeah, close to the charge, field lines are very close, means per unit area number of field lines are very much, and if you move away from the charge, the per unit area number of field lines becomes less, and number of field lines per unit area represent the strength of electric field. If the number of field lines per unit area is much more, then the field will be stronger, and if the number of field lines per unit area is less and less, then the electric field will be weaker at that point. So, number of field lines per unit area represent the strength of the electric field intensity at a point. And you also know E is equal to 1 upon 4 pi epsilon naught Q upon R square. Due to point charge, electric field intensity is expressed as E is equal to 1 upon 4 pi epsilon naught Q upon R square. Dear student, E is proportional to 1 by R square, right? E is proportional to 1 by R square. It means as you move away from the charge, electric field intensity decreases very rapidly. It is inversely proportional to the square of the distance, right? So close to the charge, electric field intensity is very stronger, and as you move away from the charge, the field lines, the intensity decreases very rapidly. Next property, dear students. Next property is the two field lines cannot intersect. If they intersect, then what happens? Look here, like two field lines. For example, two field lines are just intersecting each other. Now, at this point, at the point of intersection, one tangent you can draw in this way, and another tangent can be drawn in that way. It means at a common point of intersection, there is two directions of the field which is not possible. At a point, vector has only one direction. At a point, vector possesses only one direction. That is why the two field lines cannot intersect to each other. Why? Because at a single point, at a common point of intersection, there will be two directions of electric field. Now, dear students, we are discussing the properties of field line. You can say that field lines begin from the positive charge and end at the negative charge. The field lines begin from the positive charge and end at the negative charge. So they do not form a closed loop. Closed loop means from where the field line begin and come to that point, they form open loop, because if you consider only an isolated charge, the field line will begin like this. Yeah, field line will begin from the positive charge and will go to infinite, right? In case of two charges, positive and negative charges, field line begin from the positive charge and come to end at the negative charge, but do not return from negative to the positive charge again. That is why they form an open loop. Electric field line, the basic property, the most important property of electric field line, that they form an open loop, right? They begin from the positive charge and end at the negative charge. So, this was all the properties of the field lines about. Dear students, I hope that my videos are going to be beneficial to you. If you think that my videos are helpful in your studies, then please and please, it's my request from deep and sincere of my heart that please and please share, subscribe, comment, and must put the bell icon so that you can be notified about my next video. Soon we will meet in the next video that will be based on the electric dipole moment and torque acting on the dipole. Okay, till then, bye bye. Have got a very good day. Enjoy that day.